Okay guys, so we are starting 5.2, which is called Fundamental Identities. So if you really like algebra, this is going to be the section for you. It's got a lot of algebra involved, using the different trig functions, okay? So essentially what we're working on is using different trig formulas to simplify expressions, okay? Now, what I have right here is a big trig cheat sheet that I'll put on ArgoNet for you, okay? But what we're going to be focused on mainly in this section are these identities here, okay? The tangent and cotangent identities, reciprocal identities, and then the Pythagorean identities. Most of these I'm sure you guys probably already know, or even like when we go over it, you're probably going to be like, oh, yeah, that makes sense. So that's what we're going to be using today. So the definition of an identity is just an equation that equates two expressions that are true for all values in the domain of both expressions. Essentially, one side equals another, okay? Now, the first set is called the reciprocal identities, okay? Now, down here, right, we know that from using the unit circle, that sine of theta is equaling it to the y term, right? And then cosecant is just the reciprocal of that, right? It's 1 over y, okay? So now if you put one in terms of the other, right, you know that then sine is going to be 1 over cosecant, okay? Now, if I substitute cosecant, okay, into here, all right, so that would be 1 divided by 1 over y. What I would end up ending with, right, is just the y term, okay? So if you substitute one into the other, you'll see that they are the same, okay? So sine is the same thing as 1 over cosecant, and then cosecant is the same thing as 1 over sine, okay? So if we know that fact, that'll help us simplify our expressions, okay? The other pair you have is cosine, which you know is then the reciprocal of secant, so it's 1 over secant, all right? And then secant is going to be 1 over cosine. All right, that's pretty straightforward. And then I'm sure you can guess the other pair, right? You have tangent is going to be 1 over cotangent, and then cotangent is 1 over tangent. Okay, so those are your three pairs of reciprocal identities. Okay, now tangent and cotangent have also what's called quotient identities, okay? So tangent we know is the y term divided by the x term, right? Now if we know the y term is sine and we know the x term is cosine, then tangent has to be sine over cosine, all right? And then the opposite of that, right, cotangent, we know is the x term divided by the y term, so cotangent then must be cosine over sine. Okay, so those are the quotient identities. Okay, and then these here, these here are your reciprocal identities. All right, so you guys are really going to want to commit those to memory because we're going to be using them a lot. All right. Quotient identities, just talked about that. And then the last set that you have here is Pythagorean identities, okay? Now, if you're talking about something that's on the unit circle, right? You have a point here, right? It's on the, that's a really bad circle. You have something on, that's probably even worse, but it's okay. You have something on the unit circle, you know that that's x and y, right? And we always drew out a triangle, right? So we know that that was be x, and that's y, right? And then this is the radius, right? So to do Pythagorean theorem, right, we always did x squared plus y squared equals 1 squared, right? But now if I know that the x term goes with cosine and the y term goes with sine, right, we can just substitute that, and then that'll give us our first Pythagorean identity, which is sine squared plus cosine squared equals 1. Okay, now that's the same thing as saying cosine squared plus sine squared equals 1, right? That they mean the same thing. Okay, another alternate form is if you say you took this first equation and you solved it for sine, right? So then it would be sine squared equals 1 minus cosine squared. Okay, and then another one you could do is also cosine squared equals 1 minus sine squared. Okay, so if you guys see a problem with sine squared or cosine squared, you're probably talking about this first identity here. Okay, now you also have two other Pythagorean identities. So if you take sine squared and cosine squared, okay, and say you take that entire equation, all right, and you divide it by sine squared. Okay, what does that give you? So sine squared over sine squared is just 1, and then cosine squared over sine squared, right? Cosine over sine is cotangent, and then 1 over sine squared is cosecant squared. Okay, so that is your second Pythagorean identity. Okay, and then some other alternate forms of that would be like 1 equals cosecant squared minus cotangent squared, and then another one could be cotangent squared equals cosecant squared minus 1. Okay, so those are just alternate forms. Okay, now if you take that same equation again, now instead of dividing it by sine squared, okay, you're going to divide it by cosine squared now. Okay, what does that give you? So sine squared over cosine squared would be tangent, right? Sine over cosine is tangent, plus 1 equals 1 over cosine squared is secant squared. Okay, so that is your third Pythagorean identity. Okay, so some alternate forms of that one, right? You got like secant squared minus 1 equals tangent squared, and then the other one you could have is secant squared minus tangent squared equals 1. Okay, so again, if you it's probably a good idea maybe if you guys like would print that trig cheat sheet out, okay, and kind of use that as a reference, and then as you're working through these, you know, you can refer to that as we go through it. So what you guys want to do, use any algebra techniques that you can think of. Okay, our goal here is to simplify to a single trig function. Okay, so what you could possibly use, right, is you could factor, you could multiply out, okay, you could, you know, get a common denominator. Okay, all of these techniques are possible. Okay, it just kind of depends on the the equation that you're using, okay? So this first one, okay, I see that it's sine cubed plus sine x times cosine squared x, okay? I see that both terms have a sine x in common, right? Now, one thing before I move on, right, is, so if you have something that says sine cubed of x, okay, what that is the same thing as is sine of x cubed, okay? Those are equivalent forms of each other, okay? It's just a different way of writing it, okay? So if you're talking about sine cubed of x, right, you're really talking about sine of x times sine of x times sine of x, okay? So it's like you have x cubed, right? But instead of using x as your variable, you're using sine of x as your variable, okay? So for this example, right, we see that both of these have a sine of x in common, okay? So what I'm going to do is I'm going to factor out sine of x, okay? So I have sine of x here, and then if I factor out that from sine cubed, right, that's going to leave me with sine squared, okay? And then if I take out the sine from the second term, that's cosine squared, okay? So now I have sine of x times sine squared plus cosine squared, okay? Now you should recognize that this part here is a Pythagorean identity, okay? So if you look back at your Pythagorean identities, right, what does sine squared plus cosine squared change into? Changes into 1, okay? So we have sine of x times 1, okay? So we know that sine squared plus cosine squared equals 1. So you can substitute 1 in for that, okay? And then sine of x times 1 is just sine of x. And then you're done, okay? That's your goal. Your goal is to get one trig function at the end. All right? Now this next one, I don't have any, I mean, I see that I have secant, right? But I can't really factor anything. Now, the clue here is if you see parentheses, right? What do you do when you see parentheses? You multiply out, okay? So that is what we're going to do here. So multiply out. Okay, so if I do secant times secant, that's secant squared. Okay, secant times 1 is secant. Negative 1 times secant is negative secant. And then negative 1 times 1 is negative 1, okay? Now the middle terms obviously are going to cancel, okay? So now I got secant squared minus 1, okay? Now what does that change into, okay? Now one of your Pythagorean identities, right, is 1 plus tangent squared equals secant squared, right? Or tangent squared plus 1 equals secant squared. They're both the same thing. Now, is there any way that you could take this equation that you have over here and rearrange it so that it's secant squared minus 1, right? So if I take the, I don't know why it keeps doing that. If I take the 1, right, and I subtract it over, right, that's going to be equal to tangent squared, right? Okay, so I can substitute secant squared minus 1 and just make that tangent squared of x. Okay, and again, that's one single trig function, which is what I want. Okay, so I'm going to move this over here. Okay. Now the next one, all right? What would this change into? I guess there's probably a couple ways that you could do this. What I'm thinking is, again, using your Pythagorean identities. All right, so the first one, okay, we know is sine squared and cosine squared is 1, right? So how could I make that 1 minus sine squared? What would that be equal to? Okay, so if I subtract the sine squared over, I can take that and make it cosine squared, right? Okay, and then what is that other Pythagorean identity? So that was when we divided everything by sine. So that was 1 plus cotangent squared equals cosecant squared, right? What would be cosecant squared minus 1, right? If I take the 1 over, that's going to give me cotangent squared, right? Okay, so we're working our way down, right? Now it's usually pretty helpful if you change everything to be sine and cosine, just because a lot of the identities are in that form. So what I want to do, right, is I'm going to change cotangent, because we know cotangent is cosine squared over sine squared. That's what I'm going to change it to. So cosine squared over sine squared. Okay. Now when you're dividing fractions, right, you got cosine squared over 1, and then that's going to be multiplied by the reciprocal there in the denominator, which would be sine squared over cosine squared. And then obviously cosine squared is going to cancel, and you're just left with sine squared. Okay. Okay, now for the fourth one, I got cosine over 1 minus sine over cosine. Okay. Now I could change sine over cosine to be tangent, right? But that's not really going to help me, right? I have to try and get it down to a single term. Now, if you have two fractions, to get it down to a single term, right, what do you need to find? You need to find the common denominator, right? Because you want to try and put those two terms together, right? So the first term, right, what do I need to multiply the first term by so that it has the same denominator as the second term, right? That's got to be cosine. So you're going to multiply cosine over cosine with the first term. Okay, and then what do you need to multiply the second term by? 1 minus sine. Okay, so then you got 1 minus sine. Okay, so if we do the first one, right, we got cosine squared over. Now, what I would just keep it separate right now. Don't multiply it out, just keep them together. If we have to do that down the road, then we can do that. But for right now, I would leave it. Okay, minus, and then you got sine of x minus sine squared, right? Over cosine x, 1 minus sine of x. Okay, so I got the numerator just from multiplying here and here, right? Okay, so now my denominators are the same, right? So now I got cosine times 1 minus sine, right? Okay, and then on the top, I should have cosine squared minus sine of x plus sine squared, right? Okay, now what else could we put together? Now, if you guys look at the top now, right, you got cosine squared plus sine squared, right? That's an identity, right? That's a Pythagorean identity, right? What could we make that change into? Well, we can make that 1, okay? So cosine squared plus sine squared, we know is just going to change into 1 and then minus sine of x, still on the top, over cosine times 1 minus sine. Okay. Now looking at, right, you can factor out 1 minus sine of x, 1 minus sine of x, which is 1 over cosine of x. And then what does 1 over cosine become? That becomes secant. So again, now you're down to one single identity, or trig function. Okay, and then the last one, you got sine squared plus tangent squared plus cosine squared. Okay, now you can rearrange the terms however you want. So if I put sine squared and cosine squared next to each other, I know that that's going to become 1 plus tangent squared. Okay, and then 1 plus tangent squared we know is going to become secant squared. And that's your answer. Okay, so that's pretty much how you guys do, simplifying using the identities, right? You can factor, you can multiply out, use the identities. Sometimes you need to get a common denominator. Sometimes you need to rearrange things. Sometimes it's a little guess and check. Sometimes you'll work through it, and you might get stuck, and that's okay. Then you might just have to work backwards and start over again. But hopefully you can kind of recognize little clues throughout the way, and that'll save you some time, and that'll show you what kind of technique that you need to use. And sometimes there's more than one way to solve these things. So, how you might solve it might be a different way than how I solve it. But again, if the steps are logical and they make sense, and you get to this, if we get to the same answer, then it should be okay. Okay, so make sure you start looking over that trig identity sheet, and then attempt the homework. So if you guys have any questions, let me know. Thanks.